All right, well, I apologize for that. I guess I clicked the wrong button and stopped the prior video. So instead of starting over, we're just going to have a part 2. All right, so now what I was about to say is that we have to condense. All right, so we want to get down to 1 logarithm. And then it would become a problem like what we just did above. Or if we have logarithms on both sides, it's going to be very similar to what we talked about with exponentials, where if the logs match on both sides, then the arguments have to match, and we can set those two pieces equal. And you'll see that in the next set of problems. So let's go through problems 7 and 8 together. So notice on my left side here, I have 2 logarithms. They are added together. So I want to use that product property that we talked about earlier with logarithms. All right. And we want to combine those. So now, all right, I'm going to write this as log base 7. All right, and now I can write this as 2 times x minus 3 equals 5. So now notice I have it in the same situation as earlier by combining them, right? So now I can write this as an exponential. So I have 7 to the 5th power. So 7 to the 5th power equals, and then that would be 2 times x minus 3. All right, now this is one of those situations where 7 to the 5th power is a pretty big number, so I'm going to leave it like that, all right? And I'm just going to go ahead and just solve for x here. So 7 to the 5th equals, I'm going to have 2x minus 6. I'm going to add 6 to both sides. Add 6 to both sides. All right, so I get 7 to the 5th plus 6 equals 2x. And now I can divide by 2. All right, and then so we have this exact answer over here, right? So 7 to the 5th. All right, oops. Take that out of there. So 7 to the 5th. All right. Sure we have the right size here. There we go. All right, so 7 to the 5th plus 6 divided by 3 is equal to x. Now, what I forgot to do at the beginning is now we have to think about domain restrictions. So no issues here because that's a constant, but then I have to look at my domain here. All right, and so this says that my domain is 3 to infinity. All right, and this number is definitely bigger than 3, so it's a good solution. All right, now let's talk about a couple of details in problem 8. Now notice both logarithms contain variables, which means this logarithm has a domain and this logarithm has a domain. All right, so now once my dog start barking and kind of get out of the room. All right. Okay, now we can look at the domain of each one individually to start with. So when I look at this, the domain for my first logarithm is, let me just make that a little thinner here, all right, is 0 to infinity. All right, now the logarithm, my second logarithm here has a different domain. Its domain would be 7 to infinity. Now, what you have to do is you have to pick the one that will work for both, all right? And typically, that's the least restrictive one here, which is 7 to infinity, because notice if I took 1, it doesn't work here. If I took 2, it doesn't work here. But if I take 8, it works here and here. So you have to write out all the domains that you might have, and then you have to take the one that will work for both, which is 7 to infinity. So we're going to cross this one out, okay? So our working domain is going to be 7 to infinity. And you'll see why that's important in just a moment. So now what I want to do is condense my left side here. All right, so I'm going to have log base 2. And then I'm going to have x times x minus 7 equals to 3. All right, so now by condensing this left side, I'm now back in that same situation we did earlier. So now I can write this as an exponential. So 2 to the 3rd equals x times x minus 7. All right, so now we want to start solving. Well, 2 to the 3rd is 8, so I can write that out. X times x minus 7 is x squared minus 7x. And guess what kind of problem we have now? That's right, it's a quadratic. So I have to get it equal to 0, so I'm going to subtract 8 from both sides. All right, so I get 0 equals, and I get x squared minus 7x minus 8. All right, so now, all right, remember you have a couple choices on how you solve a quadratic. You could either use a quadratic formula or you could F it up and factor it up, and I think that's what I'm going to do now. All right, so then if you were to factor this, I'm not going to go through our area model, all right, but it would be x, all right, minus 8. And my computer is starting to slow down all of a sudden again, x plus 1. All right, so then I would set each of those factors equal to 0. So x minus 8 would equal to 0. And x plus 1 would equal to 0. So I get two solutions. All right, so my first solution would be 8. All right, my second solution would be negative 1. Now, here's why we had to have that working domain, because now I have to go back and look. Okay, my working domain is 7 to infinity. All right, well, 8 fits into that. That's good. So that's a good solution. Negative 1, not so much. So I can't accept that solution. All right, so I might end up with more than one solution, but I have to go back and make sure that it fits within my working domain. All right, so there you have it. All right, so that's where you condense to make it like we did before. Now, here's what I want to look at now. Woo! Isn't that beautiful, right? So let's look at problem 9. And notice in problem 9, all right, we have variables on both sides of our equation. Or excuse me, not variables, but logarithms on both sides of our equations. So what we want to do is condense the left side, get it down to 1 logarithm. Condense the right side, get it down to 1 logarithm. And then hopefully we can then match the arguments to each other in much the same way we got the exponential equations in terms of the same base. But before we do that, once again, we have to look at our working domain. So when I look at number 9 here, when I look at my first, and once again, if it's a constant like it is in the first one, that's no big deal. All right, so I look here, this, and I'll write it right up here, has a working domain of 2 to infinity. All right, this has a working domain of negative 1/3 to infinity. All right, so now once again, we have to pick the one domain that works for both situations, which in this case would be the 2 to infinity, because notice, all right, 0 would be in this interval, but 0 wouldn't work here. So, all right, so this is not going to work. So we're going to take that guy and throw it out. So 2 to infinity is our working domain. Now, let's talk about this particular problem. So let's condense the left side. Once again, we're adding two logarithms with the same base. All right, so that means I can use my product property. So I'm going to get log base 5, and I'm going to have 8 times x minus 2. All right, and then I look at the right side. Once again, I'm adding two logs with the same base, so I can use that same property again. So log base 5 of 4 times 3x plus 1. Okay, now, just like the exponent, if I have log base 5 of something equals log base 5 of something, those two somethings have to be equal in order for the equation to be equal. So that means 8 times x minus 2 has to equal to 4 times 3x plus 1. And there's our linear equation. So let's solve this. So on the left side, if I distribute, I get 8x minus 16. And on the right side, if I distribute, I get 12x plus 4. All right, so if I subtract 12x from both sides, I get negative 4x. If I add 16 to both sides, I get 20. And if I divide both sides by negative 4, I get negative 5. All right. So now, when I look at negative 5, notice I go back up to my working domain here. All right, negative 5 is not in that working domain. All right, therefore it is not a solution. All right, there's nothing else left. So what that means is that this problem does not have a solution. It's all finished. All right. So here's what I'd like you to do. I would like you to try number 10. Now I'm going to give you a couple pointers before you begin. Notice we have a subtraction here, so you're going to use the quotient property when you condense. And then notice you have 4 working domains, so make sure you consider all 4 of those, all right, before you begin the problem. All right, so let's take a look at number 10. All right, so I have 10 written right here. So now if we go through our working domains, the working domain for our first logarithm would be -4 to infinity. The second one would be 2 to infinity, and then -5 to infinity, and then -1 to infinity. So notice the one that we want to keep is that one, right? These, all right, okay, don't work. All right, but anything I pick in this interval will work for all of them. So that's our working domain. Now, a couple of small details here. One, we have a subtraction here. So when I subtract two things, two logarithms of the same base, that is our quotient property. So that gets us to x plus 4 divided by x minus 2 on the left side. And then on the right side, once again, we have subtraction. So that gives me the log base 5 of x plus 5 divided by x plus 1. Now, once again, if log base 5 of something equals log base 5 of something, those two somethings have to be equal. So I have x plus 4 over x minus 2 equals x plus 5 over x plus 1, which gives us a proportion. All right, so if we do numerator times denominator, that's x plus 4 times x plus 1. If we do numerator times denominator, that's x plus 5 times x minus 2. All right, and then if we distribute, we get x squared plus 5x plus 4 equals x squared plus 3x minus 10. Now, x squared is common to both sides, so that is equal to 0, so we can just get rid of that. And we get 5x plus 4 equals 3x minus 10, so subtract 3x from both sides, that gives us 2x. Subtract 4 from both sides, that gives us -14. And then we get to -7. Now, once again, if we go back to our working domain, you can see that -7 does not fit into that working domain. All right, there are no other solutions to consider. All right, oh, now I have it written right here. All right, so this is a no solution problem. All right, 2 more problems left. All right, 11 and 12. Let's do 11 together, and then I'll have you guys do 12 on your own. So let me scroll down here, give us a little bit more room. All right, so now both of these are all of my logarithms are the natural log here. All right, I have 2 on the left, 1 on the right. So what I want to do now is use my properties, all right, to condense that left side to 1 logarithm. Now, once again, it's subtracting 2 logarithms of the same base, so that's going to be my quotient property. So I'm going to have natural log, and if I use that quotient property, I'm going to have x plus 2 divided by 4x plus 3, and that's going to equal to the natural log of 1 divided by x. All right, now what I need to do is go back and look at my working domains. I should have done that to begin with. So if I have x plus 2, and I'm going to write those just right up here in red, that means my working domain for the first part is -2 to infinity. All right. For my second one, that would be -3/4 to infinity. All right. And when I look here, this one's a little different, and we haven't really talked about this, but we know we can't take the log of a negative number, and then the numerator is always positive. All right. And so what that means then, if the numerator is always positive, in order for this ratio to stay positive, we need the denominator to be positive. So that means we want to go from 0 to infinity. All right. So there you go. Okay. All right. So now, all right, there's our working domains. Now, once again, if I pick something from this interval, it'll work in these two. So we're going to cross those two out, and then our working domain has to be from 0 to infinity. All right, so now once I have a logarithm here equals logarithm here, the arguments have to equal to each other. So what we see is we are going to have another proportion here. Of course, we're going to have x plus 2 divided by 4x plus 3 equals 1 over x. And then once again, all right, solve that proportion, numerator times denominator. So x times x plus 2 would be x squared plus 2x equals 4x plus 3. And now, once again, we're in that quadratic formula situation or factoring situation because we have a quadratic equation here. So if I subtract 4x from both sides, I get x squared and minus 2x All right, if I subtract 3 from both sides, I get negative 3 is equal to 0. The nice thing is this turns out to be a problem that's fairly easy to factor. So x minus 3 times x plus 1. All right, and that's equal to 0. And so if I take both of those, let me scroll down just a little bit more here, and set those equal to 0. So x minus 3 is equal to 0, and x plus 1 is equal to 0. I get two solutions. So I get x equals 3, and I get x equals negative 1. All right, now once again, go back to our working domain. It says we have to have all positive numbers. All positive numbers. All right, so that means I can't have this guy. 3 is good, so that's our only solution. Maybe if it comes back. Oh, there we go. All right, that we would work with. All right, so I left the really fun one for you to finish this unit on. All right, so pause the video, give number 12 a shot, and I'll check back in with you in just a moment. All right, number 12 is a doozy for a couple of reasons. One, we have 3 working domains to consider. So for the first logarithm, it would be 1/3 to infinity. For our second logarithm, it would be negative 5/2 to infinity. And then for our third logarithm, it would be negative 1/12 to infinity. And so once again, we'd want to take the interval that would work for all 3, which would be that first one from 1/3 to infinity. So we'll get rid of those 2 guys. All right, so now multiple logarithms on the left, multiple logarithms on the right. We need to condense both sides. So if I use my product property on the left, I get log base 3 of the quantity 3x minus 1 times 2x plus 5. If I use my product property on the right, I get log base 3 of 2 times 12x plus 1. Since the logs match and have the same base, that means the arguments have to match. So 3x minus 1 has to equal to 2x, or times 2x plus 5 has to equal to 2 times 12x plus 1. Now, when I distribute on the left side, I get 6x squared plus 13x minus 5 equals to 24x plus 2. If I subtract 24x from both sides, I get negative 11x. If I subtract 2 from both sides, I get negative 7 is equal to 0. Now, once again, you get to a quadratic situation. You can either factor, all right, or use the quadratic formula. I chose to factor here. And once again, I didn't show the area model, but you get 3x minus 7 times 2x plus 1, which gives us one solution of 7/3 and a second solution of negative 1/2. Now, once again, if I go back, we have to go 1/3 to infinity, which means that 7/3 is the solution that works. The negative 1/2 here does not. We throw it out. And that, my friends, wraps up our unit on, all right, exponentials and logarithms. All right, you still have a little bit more work because you need to take a look at the homework and try to work through these problems on your own. But if you get stuck, you have questions, email us, contact us, see us during our working, our office hours with our Google Hangouts or Zoom, whatever we're doing. All right. Take care of yourselves, take care of each other, and we will see you again soon.